Welcome to tonight's lecture. It's going to be a fun lecture. Pia and I were talking about this just before, and we each agreed that there's certain things that we're both passionate about, and we try and teach the classes about that. So I'm very passionate about foams and emulsions. That's what we'll hear about today. That's what I do some research on. So that's one of the themes of this week. So who's been to these lectures before? Most people. Who hasn't been? Okay, watch carefully. So we always have a quiz. And remember the traditions in this class. When we see an equation, this apron has all the equations from one of the years of the class on it. So you get to wear this. So you put up your hand and you answer the question. I'll try and pick somebody, but I get to read the question before. It's based on last week's lecture. So the heat diffusion coefficient determines how fast heat moves into a material. Why is it more or less the same for all foods? Back there. The one who's looking behind. You. Pardon?
Because of the water content?
What does that mean?
So, since a lot of foods have water, the heat diffusion coefficient of water determines the heat diffusion coefficient of the food itself.
So, what's food mainly made out of? Very good. Okay, a little freebie science lesson. If you take a pot of water and heat it from the bottom, does it heat up by diffusion? No. How do you know that? What's the one thing you absolutely know? If I took a piece of meat the size of a pot of water, how long would it take to cook it? Several hours. How long does it take to boil a pot of water? A few minutes. So what's happening? It's convection. The difference in the weight and the density of the water causes it to stir. So it's not diffusion. Okay. Chef Geordie from last week made a liquid distillate turn into a solid when poured onto a plate. How did that happen? Way back. Yes? Super cooled. Super cold water is very super cool, right? Yeah. Very good. So super cold water, you don't allow the ice crystals to nucleate, so it doesn't form ice, even though you cool it below the freezing point. Then when you pour it, it freezes instantaneously. Last quiz. Chef Geordie made cigar flavor ice cream. How did he get the smoke into the ice cream? He whipped the cream with smoke. Okay, so that's going to be something we'll talk about today. What does that mean? Air goes into the cream to make the ice cream. It's filled with air. Bravo. In fact, that's what the topic of today is. That's way good. That's the topic of today. It's creams, ice cream. It's really a foam. And so we're going to talk about foam this week. Here's my favorite kind of foam. I tried to buy some. That's why I was late. I tried to buy some outside. And they said they make it, but it didn't foam up enough. So fortunately, Pia got some. And so we always like to have some demonstration during this class. So we have a demonstration. Can we do this now? Oh, look at that. This is a foam. Let me take it from here. You can pass it around. Don't drink it all if you take a sip. Okay, what is a foam? It's bubbles of gas inside the fluid. The gas doesn't go into the fluid, you have to make bubbles of it. And so foam is really a very cool thing. Can I have my slides back? So this is one of my favorite foams on top of a coffee. Notice this one, though. Notice this one. It's getting really solid-like, right? So this is sort of what I find really amazing. What have you done? You took gas. Gas goes everywhere. And you took fluid. Fluid flows everywhere. And you mix them together, a gas and a liquid, and you get a solid. How's that possible? So if you look inside, you'll see that the foam is made up of bubbles, bubbles of air. Why does it get solid? If you pack it enough, if you start to pack it, the bubbles start to deform, and it's the deformation of the bubbles that make it solid. So here's different degrees of solidity. This is just a little bit of whipped milk, essentially. It's clearly a fluid. This is the foam on top of a latte. This is a whipped cream. Same thing. It's just air and cream. And this is a shaving cream. It's even more solid. So what's happening? Well, you can go back and you can see it here. The more you pack the bubbles together, the more you pack them, the more solid they get. But the degree of packing depends on what we call the volume fraction of the bubbles. And you know that. In fact, if you remember what Pia showed us, the bubbles were well separated. If they're well separated, they move freely in the fluid, and it's just a fluid. You have to pack them enough until they start to deform. So you have to pack them so much until they actually begin to deform, and that doesn't happen if they're spherical and they're the same size. It doesn't happen until the volume fraction reaches 64%. That's a magic number. It's a well-defined number, and we can measure it, but there's no way of actually predicting it. Even to this day, it's a well-known number, but nobody can actually predict it. This is true only for spherical objects of uniform size. And so the more you pack them, the stiffer they get, but the stiffness doesn't start until you're above this value. And so the elasticity, or the stiffness of the foam, will go from something that has no stiffness, no elastic properties, to something that barely is elastic. And then as you increase the volume fraction above this critical value, it becomes more and more elastic. And we can capture that by a simple equation, which is shown here. And the important features are, it only has a value, a positive value, when the volume fraction is above this critical value here. And it depends on the surface tension. That's the stiffness of the surface. It's like how stiff a balloon is. And inversely with the size of the bubbles. If I make the bubbles smaller, it gets stiffer. There's another kind of mixture, and we'll hear a lot about that today as well, that behaves very much like a foam. A foam, I take air and I mix it with water. If I take a second fluid and mix it with a fluid, two immiscible fluids like oil and water, normally they don't mix. If I want to mix them, I get a mixture of drops of one into the other, and that's an emulsion. So a mayonnaise or an aioli is an emulsion. Whipped cream or coffee foam is a foam. This has air drops inside of a continuous fluid. This has water drops or fluid drops inside a continuous fluid. And if you look at a microscope image of this, this is of a mayonnaise. This is actually just Hellmann's mayonnaise. If you look at it, you can see the drops of the oil inside of the water. Same with aioli. Aioli is made with garlic, a little bit of lemon juice, some salt to draw the water out of the garlic, and then you emulsify, you make drops of olive oil inside of it. So how do you make the drops? And how are they stable? Why are they stable? Well, you can make them just by essentially either mixing two fluids together or mixing air with a fluid. You can do it by whisking or blending, an immersion blender. We'll see some examples with Corey tonight of how he does it in a restaurant. What happens when you mix fluids or air together, when they run across each other, they're sheared, they're torn apart, and they break into smaller drops. And you mix more and more, you make them into smaller and smaller drops. What happens if I make the drops smaller? Do you remember? Stiffness goes up. It gets more elastic. And why do they stay stable? Normally, so a good example, one of the most common examples is a vinaigrette. You mix olive oil and vinegar, you shake them up, they're immiscible, you shake them up, you get drops. If you do that just with oil and vinegar and you put it down, they'll rapidly phase separate. They'll all rapidly go back to the oil and the vinegar. But if you add a little flavoring, people like to add mustard, for example, a little mustard powder. You add a little mustard powder, a little mustard, you mix them up, it adds some taste, but it also keeps them stable. It keeps them from separating. And the reason for that is that the mustard acts as what we call a surfactant. A surfactant is surface active molecule. It's a molecule that's half and half. It's half water-like and it's half oil-like, half hydrophilic, half hydrophobic. It can't decide what it wants to be, so it always stays at the interface. And if it stays at the interface, the role of the surfactant is actually to stabilize the drops. Because if you have a coating of surfactant, and I think we show it here, that keeps the drops from merging together. As they come closer, the surfactant prevents the drops from touching one another. So the role of the surfactant in an emulsion or a foam is to stabilize the drops. So a real aioli is just garlic, a little lemon juice, some salt, crush the garlic, you draw the water out of the garlic, tiny, tiny, tiny amount of water, and a huge amount of olive oil, and you emulsify the olive oil inside that water. No surfactant except from the surfactant from the garlic, which is not a great surfactant. But now what people do is they use egg yolk because that is a wonderful surfactant. And so we had a little contest. We asked, how much emulsion, how much mayonnaise can you make with egg yolk? Anybody have idea theoretically how much it is? It's a huge amount. Huge amount. Here, this was on one of our courses, somebody made nearly 1 liter of mayo from one yolk. Actually, there's enough surfactant to make probably 10 times that amount of emulsion, because egg yolk is a fabulous surfactant. Okay, so tonight we have Corey Lee from Benu Restaurant in San Francisco. I had the real pleasure to do something with him before, so I know a lot of the things he makes, and he's going to tell us about his menu, which is just filled with foams and emulsions. So Corey.
Thanks, Dave, and thanks, Pia, for inviting me out. I'm really excited to be here. As Dave mentioned, I'm from San Francisco. I'm a chef and restaurateur from San Francisco. And I operate 3 restaurants in San Francisco. One is called Mr. Benjamin. It's a very casual French bistro. The other one is called In Situ, which is a restaurant that I opened last year, and that's kind of an interesting project where we collaborate with over 100 chefs around the world, and they pick a dish from their repertoire, and they show us how to make that dish, and we execute that at the museum. So it's kind of like a food exhibition, so to speak. And then the third restaurant is Benu, where I spend most of my time. And Benu is a restaurant that I opened in 2010. At that time, I had been working as a chef for about 15 years. I started cooking in 1995. And all my experience up to that point was in Western kitchens or French restaurants, or at least French-based restaurants. And my last position right before I started at Benu was at a restaurant called the French Laundry in Napa Valley for the great American chef Thomas Keller. And that's a restaurant that I think is very iconic and known worldwide for being one of the first kind of fine dining restaurants in America to have an American perspective and not just try to replicate French cuisine. And because I was the chef there, I had a lot of responsibility that had to do with menu development and creating new dishes and making sure that the cuisine evolved. And that was really rewarding, but there was also kind of this growing curiosity to explore some different kinds of flavors and techniques, and those are the flavors and techniques really of my native culture and of Asian cuisine in general. So that's something that I became more and more interested in. But at the same time, I knew it wasn't the right restaurant for that. You know, people go to Napa Valley, they're at a restaurant called French Laundry, they want to have that cuisine. The last thing they want is some kind of Asian influence in that. But still, as that curiosity grew, I realized more and more that I need to do something of my own. And that was really the impetus for going out and opening Benu. Has anyone here ever been to Benu? Oh, there are a few people here. Okay, great. But I figured most of you hadn't been. So this is a little video that can kind of give you a look into our restaurant. Okay. So thank you. So Dave mentioned that we're going to talk a lot about foams and emulsions. And okay, so something that we think a lot about at Bennu is texture and mouthfeel. You know, a lot of people think about how something tastes to decide whether they like something or not. But I look at it with three things in mind. One is the taste, of course. Another is the aroma, which is incredibly important. And the last is texture. So if you think of a food that you really, really like or you really don't like, and if you were to just close your nose and just put that food on your palate, I think you'd find you'd have a pretty different experience with that food you either like or dislike. And that's how important texture is in how we perceive a certain food. So that's something that we think a lot about. And to do that, we go about that in a lot of ways, but it's a texture that we want to be deliberate about. So sometimes it's a choice of ingredients. So if we're making a chicken broth or a dish with chicken soup, for example, we might put some chicken feet and chicken wings so that you get this really gelatinous mouthfeel. Maybe with vegetables, we might, a potato, we might fry it versus steaming it versus poaching it. And that one part of different texture. Al dente, sometimes we actually intentionally overcook things to get a certain texture. But the texture is really, really important. Another way we do that is actually by engineering like a system, which is what Dave is referring to. And two of those are foams and emulsions. So when I was looking at our menu, and this is our menu from, I don't know, three, 4 weeks ago, getting ready to talk about this, I asked myself, okay, this is our menu. They asked if I can talk about foams and emulsions, which is not really something I do often. But let me see how many emulsions we have. So I went down the list, and that's how many emulsions that we have on the menu. So I was kind of surprised. I said, okay, maybe I can actually do this talk. And then I asked myself, okay, well, how many foams do we have? And then it was this. So now I feel like an expert on foams and emulsions, right? And there are only 2 dishes on the menu that doesn't have a foam or an emulsion in some form. So I'm just going to video demo these dishes that have foams and emulsions. Don't worry, we're not going to do all of them. We're going to do these because I think there are different kinds of foams and emulsions. Okay, so I'll go through these one by one, and then you can see the various ways we incorporate foams and emulsions. But keep in mind that as a chef, I think there are certainly different kinds of chefs and different ways to go about it. But I don't look at a dish and tell myself, oh, let's put a foam on there or an emulsion. I try to create some kind of experience for the guest who's having this dish, and then work backwards and see how we can achieve that. And in that sense, I think it's like if you were to think about building a house or designing a building, and then there's all this engineering behind it that gives that structure support and allows that to happen. And that's how I kind of see working with foams and emulsions in our kitchen. So the first dish is a little soup, 1,000-year-old quail egg, which is basically a base-cooked egg, or pidon or century egg, goes by different names. Potage is a soup, and that's where the emulsion will be. And then ginger is pickled ginger, some acidity that pairs well and classically with the 1,000-year-old egg. So Dave, you want to join me here and maybe help explain some of these things that I do?
So I get to explain the foams and emulsions.
Okay, so this is basically bacon rendering out in a lot of butter. So a ton of fat coming out of here, right?
What's on top? Foam.
So that's onion, cabbage. We're basically making a simple soup. And I don't think you think of a soup as an emulsion. But I'm sure all of you have had a soup that's really greasy. To me, that's not an unemulsified soup. And what gives you kind of the velvety texture of a really nice made soup is that it's an emulsion. And the fat is evenly dispersed in that system. So here we're adding chicken stock. We're letting that cook. So we'll cook down until it's soft. Is that a foam?
That's a foam, but it's made of an emulsion, right?
Okay, so now we're pureeing the whole thing. Some seasoning, and then we add a little bit of whey protein to help emulsify it. And then you can see it almost turn into this very thick mayonnaise like like texture. That's just a little bit of cayenne. But there's a point where it emulsifies and it becomes almost like pudding. And, and it's starting to happen right around here. So this is the 1,000-year-old quail egg that I was talking about. This is basically a base-cooked egg. We brine it for a couple weeks in a solution of lye and pu'er tea. And then we age it for another 4 weeks. And basically what happens is it turns into this, this kind of wobbly gel with a very creamy, kind of sticky yolk texture, which is this here. It tastes a lot better than it looks, trust me. So this is a ginger sour cream, which is an infusion of ginger and sour cream. And then this is the potage. And this is a little bit of cooked cabbages that have been juiced to kind of echo the cooked cabbage in the soup, but kind of a fresh version of that. And then we serve that with the 1,000-year-old quail egg.
So the sour cream is itself an emulsion, and then he's made an emulsion on top of this. So this is an emulsion on an emulsion.
So that's the first dish. Okay, so the second dish is oyster pork belly and kimchi. So this is kind of a version of kind of a fun version of a classic pairing in Korean cuisine. Really here, it's the kimchi that we first ferment, and we make a stock, and we do a couple of different things with that. So the first thing is making kind of like, it's basically like a quick kimchi. I wouldn't make kimchi this way if I was actually going to serve the kimchi itself. But we start with cabbage, some dried chili powder, just a little bit of anchovy essence. And then we actually ferment this in a bag. So the fermentation happens pretty quickly. It takes about 3 to 4 days. But this is, we actually don't serve this because the texture of this and the flavor of this is really not very good. But when you make a stock with it, it's actually very powerful and very strong. So that's why we make it this way. So all we're doing is taking that kimchi, we cover it with a little bit of water, and then simmer it. And then we get this very intense, spicy, sour flavored liquid. Okay, so that liquid is the base for 2 things that we do for this dish. The first thing we do is add a little bit of starch, and we lay it out on these acetate sheets. And then we get an even layer that dries. And right before it's fully dried, we're able to cut it into precise squares. So those are the squares. And then it still has some moisture in it, so it's pliable. So we can take that and put it into a mold and make a little cup out of it. And then once it's in that shape, we dry it further until it's crispy. So that's the kimchi cup. But the other part of the kimchi juice that we make a gel using gelling gum. And then we basically set into gel and then puree it. And we're pureeing this with a few things. One is a little bit of soy lecithin, some different seasonings, and a little bit of skim milk. So this looks like a really, really thick puree, and it is. But the reason why we do that is so that we can whip it into a foam. And one thing about this dish that's important is that we have this hot pork belly with this ice-cold oyster. And that's something that we wanted to try to maintain even in a really small bite. So we take that puree, we put it into a kitchen mixer, and we whip it until it's really, really dense, like shaving cream. So you can see how thick that gets. And then this is just a single oyster that we're going to put on top. Well, we're just trimming it up so it fits in the cup. But then in the cup, it's too big. So in the cup, we take a little bit of the rendered pork belly, and we make a powder, and then we add hot pork belly and kimchi that's mixed together. And then we add the foam so that it separates the hot pork belly from the cold oyster. And it
See
can
how
just sit on top.
solid it is?
Yeah. So that's the oyster pork belly kimchi. Thank you.
So what I find really cool is that you can make something that's so solid,
Yeah.
just starting with a liquid and mixing gas into it.
Yeah, I mean, I think it's pretty cool.
It's cool. It keeps the heat apart.
So the next thing is this sausage. And I was not sure if this was really an emulsion. I had to ask Dave this morning. But I know, it's okay.
We define it as being an emulsion for this class. Actually, it is.
So this is another kind of surf and turf kind of dish, a little small snack that this is all like little snacks before you start. The food is not this small for the most of the meal. So this is a fermented pepper sauce that we make. It's fermented pepper based, and we add different seasonings, and then we add sesame oil at the end. And it's kind of like a thick, kind of really spicy sauce, but we just use a drop of it. This is where the emulsion is. So we take pork, and we add aromatics, ginger, scallion, garlic, green scallions, and we add mung bean jelly noodles and sweet rice, and we mix it all together, and that's the base. And this is all pork blood, so we're making the base of a pork sausage or boudin noir. And then to this mixture, we emulsify sesame oil. Okay, and sorry, this is some other seasoning mix. I don't think that's really important at this point. But after this step, we emulsify the sesame oil, and you end up with an emulsified sausage. And I don't know how many of you have made sausages before, but sometimes you make a sausage, and then you go to cook it, and all this fat comes out, right? And it's really dry, and the texture's not good. And that's from the sausage breaking. But this one, we can see how thick it is here.
So what's interesting here, Corey, is not only is it an emulsion, but it's filled with solid particles. So that's the one thing I didn't talk about. I talked gas, bubbles, liquid drops. You can also have solid particles in a fluid, and that's called a suspension. So this is the third of the 3 different classes of materials like this.
So after it's cooked, you can see that it's retained its shape. And we can actually saute this without it rendering out all the oil that we emulsified in. This is a little bit of squid. And we just squirt that squid so we can wrap it around the blood sausage. And then we gently poach it so that it's almost raw, but it's just a little bit firmer because it's been cooked. And it curls up. This is that fermented pepper sauce we had in the beginning. The pork sausage, the blood sausage, and then some pickled radishes, sesame leaf, a little more of that spicy sauce. The squid goes right on top, and then it gets glazed with a pork and squid flavored sauce. Okay, so that's the squid roast sausage. Okay, so the next dish, this is a fun dish because it has both a foam and an emulsion, right? That's super exciting. So we start here with something that you saw when Dave was talking about, which is the mayonnaise. Now I realized I only need to use like 20 grams of this egg yolk now, but this is 3 egg yolks. Some horseradish juice, mustard, some seasoning, basic mayonnaise flavor with...
So that's about 20 grams.
Oh, it's a little bit more. But this is about 500 grams of oil.
So at most 50 grams. 500 grams of oil and 50 grams of everything else.
So you can see this come together, and you can just see how thick this gets. Yeah, it comes together fairly quickly. But also, I really didn't. The only water in there is the vinegar and the horseradish juice. So
And a little bit from the egg.
yeah.
So you can see that, roughly speaking, it's 50 grams of water at most, and 500 grams of oil. That's roughly 1 in 10. So it's roughly 90% by volume, the drop phase, which is the oil phase. That's why it's so stiff. It's way up on the stiff side.
So here I'm making a little batter. So this is a cornstarch batter for like a tempura. And when I was coming up and being trained on how to make a tempura, people had this thing where they use club soda in the batter. And you put that club soda batter in a fryer and it kind of explodes, right? And then in about 10 years ago when I was working with some siphons, I realized I can just make that soda in the charger and do it last second. And so that's the batter that we use, which is basically charged with CO2. So the batter goes in, and the batter itself is a foam. So this is dry jellyfish that we're coating in a little bit of starch just to help adhere the batter to it. And then we kind of lay it out into these strands and basically wrap a shrimp or use the jellyfish to wrap the shrimp. Has everyone here tried dried jellyfish? Highly recommend it. It's very good. It has this snappy texture that kind of enhances the crispiness of the batter. So what we'll do is we'll wrap that around the shrimp, and then we'll discharge a little bit of that batter that was in the soda charger with the carbon dioxide, and then
There's the foam.
yeah. And then we'll fry that for a minute just to get it crispy and cook the shrimp. But it ends up being a very, very flaky batter. And I assume that has a lot to do with the gas that's trapped in there, right, Dave?
Mm-hmm.
So we get a nice piece of fried shrimp, season it. We glaze it a little bit with this kind of sweet, spicy horseradish syrup. And then this is some of that mayonnaise that we made, the horseradish flavored mayonnaise. Little bit of chili powder. And some cilantro leaves. This is this gold flakes, just because gold flakes. And then some fresh grated horseradish. And then the jellyfish shrimp, so it's just like a little kind of fried shrimp with a dipping mayonnaise. Okay, that's the jellyfish shrimp. Thank you. Okay, so this next one is actually a dish that I wanted to do today because Dave and I did something with this when he visited San Francisco a few years ago. What did we talk about that time?
We talked about the elasticity of the shark.
We measured the elasticity.
Exactly.
Right? Okay.
So I'll show you this, and I'll tell you a little story from my perspective of this shark fin.
So this is just to give you to kind of identify the things to look for. The egg white in this dish is actually a custard. So there's many ways to make a custard. This is an egg white custard, and that's the emulsion. We take some ham stock and we emulsify that to it, and that becomes a cooked egg white custard. But here we're making a broth that's associated with shark fin. So shark fin soup, this is a faux shark fin soup, right? This is not real shark fin. So we make a soup that's flavored with the kind of traditional flavors of a shark fin soup. And to it we add some locust bean gum, alginate, and gelling gum, and we extrude it into this calcium bath to get these gel noodles. And then we cut them at a sharp bias to get strands that look like shark fin. And anyone who's ever had shark fin soup It's really a textural experience, and the flavor is really about the broth. And it was kind of like kind of a fun dish that we did when we opened, and we've done it in different iterations. But that's the shark fin that we're serving.
So this is really a gel that Corey made, and he told me it spent about 1.5 years to experiment to get the texture just right. So he says that mouthfeel and texture is very important.
So this is the custard mix that we're making. So that was the ham stock that we made. We passed that. We combined it with some egg whites, some seasoning, and then we add, sorry, we're about to steam the custard right now. So this is some Dungeness crab, which is a local Bay Area crab or Pacific Northwest crab. And then this is some of that apare. And when we were mixing the apare or the egg white, there was a lot of air trapped in it. So we actually put that in a vacuum sealer to remove the air. So it was a foam, and we're actually trying to get the air out of the foam so that you don't end up with bubbles in your custard. And then this is some of that soup that we turned into noodles, but it's also a glaze, very rich chicken-flavored soup. And then we had some luxurious stuff back in, like Genoa ham and black truffles, because we are doing a fake shark fin, so we want to include some kind of special ingredients. And if you look at those strands, they actually look just like a real shark fin, and on the palate as well. They have a snap and a texture to them that's really similar to real shark fin. So that's the shark fin with Genoa ham, egg white, and black truffle. Okay, so this one is bread, and it's kind of interesting. I think Harold McGee did a lecture here a couple times, and he wrote an interesting article about how bread is a foam. And it's not, I don't think as a chef you go around and you're cooking and you're like, oh, there's a foam, there's an emotion, there's that, But when you start to think about it that way, it's really interesting. And basically, it helps you understand a lot of what's happening. There's a certain kind of crust and a certain kind of crumb, and certainly a certain kind of flavor that we're looking for in our bread. And they're actually all related. So the gas that's being produced while you're proofing the bread is also allowing for a different kind of flavor, or the flavor is changing as those gases are being released. And by baking something that has more air in it, you're getting a different type of crumb and a different type of crust. So we started with just some sprouted grain flour and water, and then we added the starter, and we let that proof. And you can see that it's quite elastic, and you can almost see how airy it is. It's very it's very wet. It's kind of like a batter more than it is a dough. And then we'll put it into these little bread molds, and we'll let that proof for about 5 to 6 hours. And then you can see how much it rises and how much gas is being produced in that foam. So this is that same amount after it's proofed. And then we bake it. So after it's baked, is that still considered a foam?
It's a solid foam.
Solid foam. Okay.
So the outside of a liquid foam is a liquid surrounding the bubbles, but if you solidify it, which you do when you bake it, it becomes a solid foam.
So here we're making the butter that goes with it. So we start with a little bit of water, and we do this at, you can see 37 degrees Celsius, and we basically make a butter that is still emulsified, and that we can pour into these little molds that kind of look like honeycomb. So that there's an emulsion in here as well. So this is the butter after it's been set. And
Just like a solid foam, you've solidified the continuous phase, which in this case is the
so
oil.
this is a solid emulsion, basically, right?
Yeah.
Yeah. And then we drizzle some honey that's been infused with ginseng on the honeycomb. It's basically honey butter, And then when we cut the bread open, you can see, I guess, the solid foam, and you can see the air or the gas that was inside of it. Yeah. See all those pockets? So that's the sprouted grain bread with honey and ginseng. Okay, does everyone know what a xiaolongbao is? It's like a soup dumpling or Shanghainese dumpling. I decided to do this dish today because, one, there's actually a foam in the batter, or the dough, just like the bread. But it's actually, we're taking basically the opposite approach to the blood sausage, which was an emulsified sausage, and we're intentionally making a sausage that's not emulsified to get a certain effect. So we start with this filling, and this is lobster and shrimp that's being ground. To this, we make a lobster consomme or lobster stock, and we turn that into a gel, and we grind that as well. And we also take clarified butter and grind that through the grinder as well, and then everything gets mixed with lobster coral. So you have almost equal parts of the clarified butter, this gel that you see going through. On the top, you can see that it's this brown gel. That's the lobster stock. And then we roll them into these little balls. So right now, they kind of look like a sausage, right? Just like the blood sausage, or solid suspended in an emulsion. And then this is the dough. And we use a yeast dough, so because we want it airy, and when you bite into it, it's softer than like a cold dough. And that allows you to get some strength from the dough, and it can be a little bit thicker, but when you bite into it, it's not this hard, firm dough or wrapper. So this is dough after we've sheeted it a few times, and then we punch it into these little circles, and then we roll them thinner to get the sides a little bit thinner, because that's the part that gets pleated. And then we put inside of it the farce that we made, or the filling, which is basically the sausage that we want to break when we cook it, or we want to separate into liquid and fat when we cook it. So so this is the, after we steam it, we serve it on this thing, so that's how it gets served. But if you never had one before, I think the next shot will kind of give you an idea of what it's like when you eat one. So you have this dumpling that's like super, super hot, and then you bite into it, and then you expect it to be like a sausage filling, like most dumplings. But when you actually bite into it and break the skin, you get this huge rush of hot, well, in this case, clarified butter, and lobster consomme that just kind of gushes out, and it's just kind of a really impactful bite. So
that's when you break the emulsion, you cause the drops to coalesce, and that's what he's done when he's heated them. And so it's no longer an emulsion, it's just a mixture.
Okay, so that's the lobster coral xiaolongbao. Thank you. Okay, so this is the last dish, and this is kind of like a sweet dessert, and this starts out with, when you guys think about a foam in food, for me, the first thing, I don't know, what is the first thing I think about? What is the first thing you think about, Dave?
Depends. If it's in the morning, I think of the foam on top of a coffee. If it's in the evening, I think of foam on top of a beer. How about you?
I think of a meringue. That's the first thing that comes to mind.
You have a sweet tooth.
And really a macaroon. So this is a French-style meringue. First we made the egg whites, and now we're whipping separately the cream. And then we combine the cream and the egg whites. So we have two foams being mixed together. Then here we have creme fraiche, which is basically like sour cream. And we add gelatin to that, and we mix that in, trying to maintain as much of the air as possible. Try to keep it as light as possible. And then we pipe it into these little half dome or half sphere molds. And then we freeze it. And the reason why we want it to be airy and frozen is so that when you bite into it, you're not biting into this solid, dense, like ice cube, right? If you were to take those same flavors and not whip it and put it in the freezer and you were to bite into it, it'd be a terrible experience. But because it's so light, it just kind of gives way to you, and it melts very quickly in your mouth. And that's a nice sensation. This is a winter melon that I'm trying to break apart. And so we take we clean up the winter melon, we take the seeds, we take the rind off, and we cut into small pieces that we braise in a little bit of chrysanthemum tea. So it is actually kind of savory. It's sweet, but it's still somewhat savory. And chrysanthemum is a pretty delicate flavor, especially the flowers. So we want to combine it with something that is not too assertive, like winter melon, and then a little bit of fresh cream. So we cook that down here, and then we end up with this kind of cold, almost puree sauce of winter melon that still has some texture. This is some oil being mixed with the greens of the chrysanthemum, not the petals, but the greens. And we make a really bright, flavorful herbal oil. And so we put a little bit of that green chrysanthemum oil down first. And then after the whipped meringue and cream has been frozen, we can take it out of the molds. And we can put it here. And that thing is so light, it probably weighs like maybe 5 grams. And then some of the braised winter melon. And all this is served very cold. And then we took some of the chrysanthemum tea liquid, we sweetened it, thickened it a little bit so it becomes this glaze on top. And then we finish with some candied chrysanthemum flowers. So that's the last dish. Thank you.
So we'll take questions, but let me start. So Corey, maybe you could explain, you don't think of foams and emulsions, but what do you think of when you use them?
I think of the experience that someone will have texturally. I think that when you have a foam, it really does affect how things taste, and if you have something that's really refreshing, let's say a lemonade, for example, and you were to turn that into a foam, and you're really thirsty and you want to have this great refreshing glass of lemonade, it's going to be not as refreshing, and it's really going to affect how you perceive that cup of lemonade. And same thing with an emotion. If you have a lemonade and you want to add to that a little bit of oil on top, and you have them just like that, it will be broken. But if you were to emulsify it together, drinking that will be a total different experience.
Right, so you're taking a fluid or two fluids, and you're making it from something that just flows like a liquid into something that's more solid-like, but it's not so solid like that, so you can bite it, you can chew it, you can just break it with your tongue. So it's a very, very soft solid, and that's the amazing thing about these. Okay, so let's thank Corey one more time.
Thank you.